And welcome to CS Tutorials. In this tutorial, I am going to discuss about registers and variables in assembly language. In C language, we allow to create variables of different type like integer, long, float, etc. But in assembly language, we can create variable as well as we can use registers. Now, uh, before going towards the variables and register, first I want to discuss about the memory segment. Basically, our memory consists three segments: data segments, code segment, and stack segment. In data segment, we basically store values which we create as a variable in our program, and in code segment we store instruction, and in stack segment we store return address of different functions. Now registers. What are registers? Registers are basically used to store data, and these are the part of the microprocessor. We can access register faster as compared to memory. Like we can access register in 1 to 4 nanoseconds while we can access memory in 80 nanoseconds. Now types of registers. Since we are discussing about x86 machines, so our register which is 32-bit processor, so registers in our processor will also of 32-bit size. If our processor is 64-bit, then size of register will be 64-bit. But we are discussing for 32-bit processor only. Registers are of different types: general register, control register, and segment register. But control register and segment register we are not part of this tutorial, so we are only discussing about general register. Now general register are further divided into three parts: data registers, pointer registers, and index registers. Data registers are basically used for arithmetic, logic, and other operations. And also we can move data to move variable, and we can also move data to register to move to other variable. Now these registers are AEX, ABX, ACX, ADX. The, these 32-bit registers are divided into 16-bit register, which is AX, and this AX register are divided into 8-bit register, which is AH and N. Like you can see in the screen, AX, which is this 4 is AX, and 1 to 7 is AL. 1 to 7 bits are AL, called AL registers. 8 to 15 bit are called AH registers, and 0 till 16 bits are called AX register. Similarly, for EBX register, 0 till 7 is called BH register, and 8 till 15 is called BH register, and 0 till 16 is called BX registers. Now, besides data segment, these registers are also used for different purposes. Like AX register is also used for different operations like multiply. If you multiply any variable, any operand with other operand, first operand should be moved to AX. Similarly, in divide, if you wanted to divide two numbers, one number should move to AX register and we simply divide it. Similarly, if we want to call some function, like we want to print any data, so that data should be in AX register. Similarly, BX register is used as a base register. CX register is also used as a counter register. There are many instructions like loop ZX, which expected CX register as a counter register, or that the which expect that the ECX consists of a number how many times we want to execute the loop. Similarly, DX, which is also used as a data register, and is also used with AX register along with DX for multiply and division operation involving a large group. Now, pointer registers. Pointer registers are for EIP, ESP, and EBP, and their 16-bit version are IP, SP, and PP. There are three types of pointer registers. Instruction pointer basically points our next instruction. For example, if I am in code segment, I am performing this instruction, then our instruction pointer will point this instruction, because I want to perform. After performing this instruction, I will move, the microprocessor will go to instruction pointer, and it will find that instruction pointer is pointing this memory segment, so it will execute the instruction written in this memory, in this bar. Now for now stack stack pointer basically provide the basically points the stack segment. For example, our stack pointer is stack segment is started, so SP which is on this location in our memory. So now for base pointer. Base pointer are basically used in function when we want to pass any parameter to function, or we expect any parameter from function, which we will discuss in detail in functions tutorial. Index register basically store offset or address of any particular memory address. They are also used for addition and subtraction. These registers are basically used in arrays and store the address of base address of array. Now this is my microprocessor. As you can see in my microprocessor, these are the registers. As you can see in microprocessor, these are the registers where AX, ABX, ECX, EDX, which are general purpose register, ESI and EDI, which is also used by users, so you can call it as a general purpose register, where ESP is stack pointer and EBX are base pointer. EX are further divided into AX, which is 16-bit register, and AH and AL, which is 8-bit register, are also part of AX register. Similarly, EBX is divided into BX register, which is 16-bit register, and BH and BL are part of 8-bit register of BX register. And similarly for ECX and EDX. Now, variables. Variables are basically names which we give to specific memory bar or bars. There are directives which use to create a variable. A directive is basically a command in the source code that is recognized and acted upon by assembler. For example, if I want to create a variable of 8 bits, I will use directive of byte, and in older version we use define byte, which is db. For 16-bit register, for 16-bit memory, we use word directive and define or define word, and for 32-bit directive we use define word, we use double word or define double word. For 64-bit memory we use quad word or define quad word, which is TQ. These directives are basically for positive or unsigned numbers, and to store negative variables in memory, we simply add word s. Now s byte defines signed byte. S word is used for declare signed word variable, and sg word is used for signed double word, and sq word is used for signed quad word. As you can see, byte which allocate 8 bits in memory and have range 0 to 255. Similarly, signed by S byte, which is signed byte, it's also allocate 8 bits in memory, and we can store -20 and create 2 plus 127. Similarly, for word, which is 16, which allocates 16 bit in our memory, and we can store 0 to 65, 535, and similarly for other variables you can see. Now syntax to declare variable. For example, if I want to create a variable of name var1 of type byte, and I want to initialize with 8, so I can simply write it as var1 byte 8, which allocate 8 bits in memory, This is my memory, and each bar is of 8 bit. And when I write this command, my microprocessor will simply allocate 0001 address to VR1 and give value of and store value 8. Similarly, when I assign another variable of type word where question mark shows it is uninitialized. So then microprocessor will allocate memory of address 002, 003 to VR2. Similarly, if I write this command, variable 3 will assign 004, 005, 006 and 007 will assign to variable 3, and 98 minus 98 is stored in this memory, which is basically waste of our memory. Now to conclude, you can see that it is our memory in which it is data segment, it is our code segment, it is our stack segment. In data segment, we can store values of variable like I store it 8, minus 98, etc. In code segment, we basically store instruction which we given to our microprocessor, and in stack segment we store returning address of a function. For example, if I call to any function, then return address of this function will store in stack. Now, why we are using register if we have variables? In assembly language, we cannot move data of one memory to another memory directly. First, we have to move to register. Then, from register we move to another memory, which we will discuss in my next tutorial. Now, if you have any confusion or you want material of this video, you can visit my blog. The link of my blog I have already posted in my description. If you like this video, please like and subscribe my channel. Thank you.